So today's session is all about system design questions. Before I go into that, let me introduce myself. So my name is Vidhi Sharma. I'm currently working as a customer solution engineer for Google. It's been like more than 5+ years with IT industry. And in terms of education backgrounds, I have a master's in computer science. And in terms of coding, I was a Java developer before, but currently my favorite is Python. And as a programmer, it's always going to be changing. So that's a little bit about myself. During today's session, I'm going to first going over what is HiCounselor, what they do, and then introduction to the system design. And then there are two problems that we're going to go ahead and solve together. Starting with like how HiCounselor. So HiCounselor is an innovative job search program that's going to help to like land you on a job. And believe me, so many times like the candidates is right, but there are so many things that they are not doing right to land on a job. Like here you get a mentorship from industry leaders, interview preparation, you have access to network for more than 200+ partners, and there is a zero upfront enrollment fee. So then once you land on a job, then you owe something to a HiCounselor. Otherwise, there is zero upfront enrollment fees. And a lot of people are taking advantage of the service. So try to look more. And if you have not enrolled, see if this is something that interests you. Okay. On that note, I'm going to go ahead and jump in introduction to system design. Now, system design is one of the interviews that is going to be there. Either it's like a FAANG company or any companies which has like either it's a mid-level or a senior level, and sometimes even for a junior level. It depends on company to company a lot. This is one of the interviews. So there are like series of interviews that happens during the process, the hiring process. So some of them are like non-technical, more of on a behavioral, but this is one of the important round, which is like if you can design a system, because at the end you're going to build it. And so many times it's like developers are involved in the designment or architecture because they are the one who's going to build it. So that's why it's very important for any developer to know that how to design a system or how things works together, or even plan for the things. So first is, what is system design? So it's just a process to define like a different interfaces, modules, component, data, database design, and then to combine all these to actually meet the specific requirement. There are some certain steps that anyone can follow, or these are totally general. One thing I want to talk about in system design is there is never a wrong answer. You can design any system any way that you feel right, but make sure whoever is asking you that question, they are on board with that idea. And I'm going to go in detail when we talk about the problem, but always understand that for system design, there is not just like a one answer to it. There can be multiples and thousands of ways a single problem can be solved. So first is clarify and agree upon the scope of the system. So for this one, let's say they have given you a system. I'm going to go to our first problem and then coming back and forth to this points. So let's say here's the problem is we need to design a parking lot system. So let's read the problem statement first. A parking lot is an open area designed for parking cars. We will design a parking lot where a certain numbers of cars can be parked for a certain amount of time. Now, while you're reading this, make sure you're grabbing those words that's going to be important for you to design this kind of system. So I'm just like, here are notes, and just like this problem is introduced to me, and I'm going to take some notes here. So first of all, there are certain numbers of cars. That means for sure there are n or maybe more numbers of slots for the car. Then for certain amount of time, that means parking time is important. Then let's read the next one. The parking lot can have multiple floors. Okay, so it can have multiple floors, and then each floor carries multiple slots. So again, multiple slots, or I think our first point also covers it. Then each slot can have only one single parked vehicle in it. We can incorporate an automatic ticketing system in the design, so customer can park their car without any human intervention. So okay, so now this is a problem statement. Now let's go back to the first step. What I was talking about is scope and agreement. So here it's scope and agreement with your interviewer. So let's see, going back to the introduction to system design page, like who is going to use the system? Now in this problem statement, it's pretty clear, like anyone who wants to park the car. So anyone who wants to park the car. Next thing is how they will be using the system. So there are multiple ways they can use it. So here you need to come up with your ideas or asking questions. One very important step of any interview, regardless if it's a system design or not, ask question and ask plenty of question. Don't assume things. It's fine even if you assume, at least say that this is my assumption. So you can say my assumption is that a person is going to come and they going to prepay for their parking, that I'm going to park only for 3 hours. And then if they don't pay for it within that 3, or they don't leave within that 3 hours, then when they get out, they need to pay more. So something like this. And then maybe your interviewer is going to say, no, let's do one thing, that the person pays at the end, depends on how many time they have, or for how much amount of time they have parked their car. And likewise, you are coming on agreement that what you want to do. Okay, so we want to say, let's say payment at the end. Perfect. Okay, now let's think through this, that do we also, like when a person comes to this parking lot for a better user experience, do you want to tell them like on which floor which slot is available? Now this you can either ask your interviewer, or if you are like very much on board with this idea, you can tell that how about we include this, that if you want to also show our user that which slot is currently available. Okay. Now, let's go and let's talk about other things. So one is we talked about scope. You can still talk more if there are more point of questions that you have, but I'm going to move a little forward here, that we want to see now the next is constraint. So constraint, that means how much data that we want to store and how much traffic is going to come and look for that piece of information. Like for example, if you want to go to like an Amazon website, obviously there are multiple people, or I would say millions or billions of people are trying to go to Amazon website at the same time. So it has a lot of traffic. But for this parking lot system, maybe 2 or 3 people wants to use it at the same time. So you can convey this to your interviewer is like, I think that we don't have to worry about multiple requests at the same time. It can be either maximum 2 or 3 people are trying to get this piece of information. So maybe 2 or 3 users trying to use the system. Okay, then so that means we don't have to worry about scaling this up. Now it's completely to your interviewer. Sometimes it's like, what if I create this this system and I want to use this at multiple parking lots? Then it's like, oh, okay, then we want to scale it, because then it can be like hundreds or thousands of requests. So again, make sure you can clear this with your interviewer. I'm gonna cover this at the end, that what if we want to scale it. Then always ask them like what level of design they want to see. Like sometimes they even don't want to go in detail. They're more of a, like, if you understand different components of system, that's only they want to get idea about it. But always start with like, do you want me to go like a very deep level and coming to a higher level, or I should start with high level structure and going down to like a deeper level? Most of the time it's like they're going to ask you to create a high level design and then break it down to the smaller level. So that's the way we're going to go about. So first higher level, and then high level design, and then going down to the lower level design. Okay, next is for this component design, talk to them is, are there any third-party API that we'll be using? Like what kind of design that we want to do? Now, it's a payment, so there are chances that, or most of the time, there is a third-party API involved. Either it's like a Visa, MasterCard, or different kinds of APIs. So for sure, there are some third-party APIs. And let's say there is a payment API that we need to use because we want to make sure our user is able to make a payment there. Likewise, ask if there are multiple questions in your mind related to it, you can say like, okay, how we want to do this thing. Then database schema design. This is so important. I'm going to talk about when I start designing, but still we are in the phase where we are asking questions. Again, it doesn't mean that when you start designing, you cannot ask question. You can still ask question, but initially spend as much time as you want in asking a lot more questions. This also gives them an idea that you are aware about so many little things and you can think ahead of you that this is how you want to build any system. So that's why it's pretty important. And let's see. Understanding the bottlenecks. I think these features we're going to talk about when we start like structuring it, because when we create a system, do we want to cache some kind of memory or not? Do we need a load balancer? Because at the same point, there are multiple requests coming in, then we need a load balancer. I'll talk more about it, what are load balancer and how we can do caching. And also, if you want to scale the system, again, at the end, if you want to use this parking system at multiple locations, then how we can use it. Okay, so far, these are some notes that we either took it from problem statement or we asked a question and we got certain answers to it. So I'm going to go ahead and copy these. Now, for system design interview question, every company has like a little bit different. Sometimes they tell you just open like a Google drawing and start creating your system design there. Some has their own tool. If you are going in person, they might use like a whiteboard there. So I would say just practice it either on a piece of paper or some kind of drawing tool that how you want to do system design. So I had this, I created this board before so that we don't waste a little bit time there. So let me go ahead and let me see if I can paste this. Notes, perfect. Okay, and perfect. So we paste all of our notes in here so that we can reference it back and we don't have to go to like a different window for it. So this is a really nice tool. I really liked it a lot. So, but it's completely up to you, whatever tool you want to use. Now, you can tell them at this point that I have a good understanding of what system we want to create. So let me go ahead and get started. But in meanwhile, if I have any other question, I'm gonna throw it there. And this is more of going to be like a pairing program or pair programming. It's not going to be like you are the one who is answering question. Your interviewers for sure are going to give some input. If you are going totally in the opposite direction, they're going to tell you is like, let's don't worry about it right now. Let's concentrate on this. Or maybe they ask you question, and if they interrupt you and ask question, please do not lose your confidence or anything. It's completely fine. They just want to know your understanding, like what you are thinking. Second important thing, make sure you speak like at the time I'm drawing and I'm not speaking anything, they're not going to understand what you're trying to do. So they might like, they're totally like out of focus, is like, oh, I don't know what this person is doing. So make sure whatever you're doing, you're telling them that what's your reasoning behind this specific thing. Now, how I would like to do system design, I basically start with like a high level and divide them into 3 parts. One is backend, one is front end, and one is database. So I start with like backend, front end, and database. Now it's completely up to you which one you feel more confident with. Like you feel I'm good with front end, start with front end. Tell them that I'm going to try to design the front end first, then I'm going to go to the back end, and then I'm going to talk about database. That's one thing. If you feel like you are more of a backend person and you can design this API first, go ahead and do that. So it's completely up to you. Now, when you say, oh, I want to design front end first, but they want to see your thinking behind the database, they might tell you like, how about we start with a database? So it's completely fine. So be prepared for those kind of like ask at the point, is like you want to start it with front end and they say, oh, how about you start with database? Just be confident at that point and start with database. Today, I'm going to start with actually database and then go to my back end and then going to my front end. And you can always like come back and forth. That is completely fine. Now, after looking this piece of information for my database, what are the things that I need to store? Or basically, what are the tables that I want to go ahead and store? So let's say we have certain number of floors and each floor has multiple spots or slots. So for this one, maybe I create like a table called car slot. And what this slot will have is, let's say, obviously, it's going to have some ID. And this is going to be the primary key. Now, if you all are not familiar with database tables, I would recommend that some companies really want that you understand it like in and out. So make sure you at least create a table structure. Not necessarily go too much in detail, but at least you can hold on a structure of a data that you want to store. So let's say for class slot, I want to store the ID. I want to store the floor number, which is going to be integer. Let me put a dash here. And then another is, let's say, slot number, because there are multiple slots on this same floor. So this is one table that's going to hold the information of car slot. Now, let's see that when a person comes, let's say they comes to this parking lot, they're going to put like, okay, I have this car, and do you all remember we want to show them that which slots are available? To do that, how about I add another field in my table, which is going to be like, is this occupied or not? And this is going to be like a Boolean field. So I want to make sure if this is occupied or not. Let me do this in different line. So ID is going to be integer, again, a primary key. Floor number, again, it's going to be, it depends. You can take it as integer. Some people also like building A and then floor number 2. Then you can choose different kind of like data type. Slot, again, we want to say integer, and occupied is Boolean. That means the slot has been taken or not. Now, let's go a little bit in detail over here. Is what if we also have this slot has some kind of car types, like it can hold a compact car or it can hold a truck? Because if we go more in like a real life example, when we go to a parking place, there are some spot only compact cars can park, on some only trucks can park. So you can also use this information to add it. So let's say type of car, which is going to be string. That's the data type. Okay, now let's go and think through this more or other piece of information. So when the person comes in, they're gonna say like, okay, I have a compact car. When they click on that compact car, it's gonna show, okay, we're gonna try and find out if there are any occupied or if there are any not occupied places available for a compact car. We're going to show that these places are available, and then they can go ahead and use this information. So we are good on that front. Now let's talk about this payment, because yeah, for everything we want to make sure that the car is parked, and plus wherever that car is parked, for how much amount of time that car is parked, so that we can figure out the payment. So for this one, first of all, I might need a table called pricing table. Now what this table will do for me is that do I care about what type of car it is? Usually it's not going to be the case, but you can always ask this to your interviewer, that am I going to get like a different prices for different cars? So they will say like, no, there's nothing. Then it's like, okay, so there's the same price for all the car. Then we might not need this table at all. Do I strike through this? Okay, never mind. It's not letting me, so I'm just going to cancel it. That means we don't need a pricing table. But if your interviewer says that, yeah, we have a different prices for different type of car, we might need a pricing table there. Coming back to the payment point, is like we want to see. So let's call this table like parking info. What this table will consist of is, for sure, one is ID. Second is, let's say, car details. And these details can only be a car number or anything. So I'm just going to put a string in there. Then with the car details, we will also want to see like what was the time that it was parked. So like, let's say we want to call this starting time. So we will have like a time and date data type there that we want to know, and also on which car slot this car is parked. Again, it's more of a question to ask your interviewer, like, do I care about in which parking lot this car is parked? And they're gonna say like, yeah, we need that information if later we want to do some analytic or something. And either they say no, then obviously you don't need it, but let's go ahead and put that there. So we're gonna say car slot. This is gonna be integer, but this is going to be the foreign key. Foreign key is something like primary key in other tables. So car slot is our table, and this is going to be the foreign key for that car slot's primary key. So this is another piece of information. Now, with the start time, yes, we also need the end time. So basically the time they get out. So at the end, when we have like, oh, this is the final payment, we can go ahead and add that payment here. So I can also add the payment information. Let's take this as a float. So we're gonna also add that payment information in our parking info. Okay, everyone. So far, so good. You can use like reaction, thumbs up. If there are any questions, feel free to put them in chat, or if you want to unmute yourself, I'm going to give like a minute there if there are any questions before I go and now start drawing things out. Okay, let's move forward. For sure, that was less than a minute, but we're going to go ahead and get started. Now, do you all see like it's almost 20 or more than 20 minutes that we took without drawing anything, because we are discussing so many of the future things, like how we want to do this and things like those. So now let's go ahead and talk about this. So first is we created or we designed our database. Now let's say we have this database. Yeah, here, and let's take this shape. Usually during the coding interview, they're not going to worry about like how you are drawing your database. but I see like it's more of like this design, but totally during coding interview, they're not gonna tell you like, oh, why you are using this way. It's completely up to you, however you want to do that. One quick moment. I thought there is a text.
It might just be the T that you see. Yeah.
Yeah, it's like before they used to call this something else, and then little change. I appreciate. Okay, so let's call this data. I just type. Oh, okay. Database. So this is a database that's going to store all of these tables for us. Now let's come to this bigger component, which is, let's say, a backend. So let's go and let's do backend here. Now, obviously, our backend is going to talk to our database. So you can create these two arrows. So because they are talking to each other. Okay, so database and backend is going to talk to each other. Now for the backend, let's design an API. Like, what are the methods that we're going to need, or what are the endpoints that we're going to need in our backend? So let's start with, first of all, that when a user comes in, we want to design an endpoint, which is going to give us like the empty slots, right? Everyone, empty slot. Now, because when a user comes in, they can see like which slot is empty. Second is, okay, let's see what are the other things that a backend, or what are the other endpoints that we know on the that we're gonna need on the backend side. So second is, let's say we found the spot, they park, when they leave, now they want to pay. So basically, second one is calculating the price. And for this one here, do you all remember we didn't store that the pricing information in the table, because we said like it's going to be X amount for each one of, or each slot, it's going to be X amount, and depends on how many hours they were there. We're going to find that out. So you can always say like, this is the method that's going to find out that how much price they are going to pay at the end. So calculate price is again are going to be our endpoint. One is, after calculating the price, they need to do a payment, right? So we're going to say payment service. Now here comes the part. Do you remember we were talking about like a payment API? So there is always going to be like a third-party API. I should not say always. Most of the time, some users have their own kind of like payment system. But if like you're using Visa, MasterCard, Discover, Amex, and different kind of credit card, you want to call their API with the card's information so that you can charge them. So at this point, even though your payment service is in your backend, but that should be calling another service, which is the third-party API. I'm going to put this little bit outside of my backend box, and I'm going to say this is a third-party payment API. Okay, so this service is now going to be talking to our third-party payment API service. Okay, so it's going to call it so that the user can go ahead and pay it. And once they pay, they are good to go. Now, one more, if we think through this a bit more detail, that we find empty slot, we'll calculate the price, we did the payment service. So most of the things are going to be filled, but how are we going to fill these details, like start time and ending time, and also like if the car is occupied, or basically the car slot is occupied or not. So for this one, we can have, again, like another endpoint that, let's say, add car parking info, this one endpoint will make sure that it updates the starting time of the parking. This if also change the occupied for their car slot, add that car slot details in your parking info, and also adding the car details in your parking info. So this is a add parking info endpoint. And also at the end, when it's calculating the price, now this is more of a discussion that you can do with your interviewer, that I can think my calculate price can first update the end time of the parking or car parking info, and then calculate the price. And your interviewer might say at that point that how about we create another endpoint for this, or you can say that how about I add another endpoint for this, and there's just going to be like update the end time. Okay, this is now your backend. So first we designed the database, then we came to the backend. Now let's go to our front end. Now again, it's if your front end is your stronger point, spend more time there. So it's always depends on like what do you feel is going to be your stronger point. Let me see if I can drag this, or it's not. Let me see if I do that. Okay. Perfect. And yeah, so let's go, and this is our front end. Now for front end, let's say that what happens. So it's like a application that's running on a system that is just put in outside of the parking spot. So when they come in, they're gonna have like, let's say, a view of let's just call it like a starting screen. Now this starting screen is going to ask them a couple of questions. One of them is, let's say, a type of car, because we need it. We want to know that if the slot is for that kind of car is available or not. And I think that's initially it's going to be enough information. Now, when user fill out this information, this front end view is going to talk to our empty slot. Our empty slot is going to talk to our database. I already have those two arrows there, but if you want to go ahead and create one more, my bad, you can go ahead and create it, but try to make this as less complicated as possible. Don't draw arrows all over the places. Then it's going to be a little hard for like your interviewer to access those things. Okay, now next is once here is your slot, and they're gonna go ahead and then start taking, or maybe on the front end side, here comes that when the empty slot is giving out the information, like let's say it's gonna give out information to our next view, and in the view we're gonna say like take your ticket, and this can be like a physical ticket, but this view can need to send some signal to actually a hardware that is actually printing out the tickets. Again, you don't have to go in details, but tell them this piece of information, that there's going to be a hardware that's going to printing the ticket. So we're going to need that piece of information. So let's say here is like another hardware, or we just call it like a ticket printer. And then let's say you can either just from the backend, you can send like two signals. One is going to go to ticket printer, that's going to give our user like, here is your ticket. Now, next thing is, this is a first thing, like when they enter in the parking garage. When they get out in the parking garage, at that point, before even showing them like the payment information, they need to like submit or show their ticket, right? So for this one, again, there's going to be some kind of hardware, or let's say like a sensor that's going to find out the ticket this is going to send the ticket information to calculate price. Again, now this is getting a little bit messier. So let me move this arrow like that. Yeah, we don't want to make our design messy. Okay, and then when this is done, we're gonna, oh, my bad. Actually, this needs to be the other way around. Like when this screen is showing up, they need to go ahead and show their ticket to the sensor. Once ticket has been shown to the sensor, then they want to go ahead and like this is service is going to call, which is like calculate the price. Then they need to obviously present their card. So basically make a payment, and then that make a payment will call the payment service endpoint, and we're just going to go ahead and do all the payment. Now, let's think through these 2 points that we added at the end. So let's say we want to add a car parking information. So when the starting screen come and take your ticket screen come, you can either show it at any of those views, but I would recommend when they are taking the ticket. There are chances of user come to the I don't know, screen, but they didn't actually print the ticket. So that's why it would be better to only add the information when they have taken the ticket. So here, and then we can also say updating the end time can be here when they are like, okay, here's my ticket, then we can go ahead and update the end time. Okay, so this is like very simple, very basic parking lot system. There are still a lot more details that can be added over here. Before I go, I see there is a question. Abhishek, do you want to yourself?
Oh yeah, that was my question. Like, when would you update the parking?
Okay.
Like, when the time was.
Okay, got it. Perfect. Yeah. So it's because those two were like I said, you can either do it or not. So that's why I just said like later on, if you are adding those, you can go ahead and do that. Okay, now here, let's think through the scaling thing that I was talking initially, that what if we want to use the system for like multiple users? There are like lots and lots of users for it. So for in those scenario, let's say this is the same system, but we want to use it in multiple places. So there are multiple requesters are coming in. That means this system needs some load balancer in front. So we're going to put another layer over here, and we're going to call this like load balancer. LB stands for load balancer. Now, what load balancer does in general is when they are like hundreds, thousands of millions of requests coming in, they decide, because then now it's not going to be only one server. Again, server is just a simple computer, but now you're going to need multiple servers because you have a lot of requests coming in. So we want to make sure not all the requests are going to the same server. We want to send them to different server, and we want to balance the load of the server. So that's where the load balancer comes in. Now there are different algorithms on which load balancer runs. There is a round robin. That means like it's going to give, let's say you have 5 server, it's going to give the first ones first, second, third, fourth, and fifth. It's just going to try to distribute equally. That's round robin. Then there are different ones. So it's basically, I would highly recommend that you go ahead and read about this load balancer, because this is a time you're going to talk to your interviewer is like, what do you think that how we want to distribute this request? There is like a weighted round robin. That means all the server has like some weightage. Let's say server 3 has a weight of 5 and server 2 has weight of 3. That means until the 3 requests, we're going to send it to server 2. And until the 5 requests, we're going to send requests to server 3. So it just depends a lot. So that's why there are different algorithms, but basically you're going to need load balancer so that when the request comes in, we can equally distribute those requests among our different server. So server, again, is just creating a replicas of the system that we just created. Okay. Now, there is another piece of information which is very important, is like replicating, or I would say just making copy of your database. Let's say your database is stored on a server in Dallas, and there was a snowstorm in February. What if the server fails? You don't have a data to like go and talk to. What happens at that point? So that's why you are replicating your database at multiple locations. Let's say one you have in East Zone, one you have in the South, one you have in the West. So that what happens is, let's say the South request is going to go to the South database. But let's say for some reason, weather or anything, South one is down, you can make a request to the East one or the West one. So that's why data replication or database replication is also important. Now, if you have a question that how you're going to show that in the design, so there is let me just quickly finish this. Your load balancer is just going to send requests to like different servers, but then this is your database. You're just going to have like, let me see if I can. Perfect. You're just going to have like multiple databases like that. But even though when you're talking to your database that is located in the South, as soon as that database is updated, it's going to make sure that it updates the other two databases as well. Not just like, oh, I'm the one who's like updated. No, all of your database needs to show the exact same piece of information. So that is also important in there. Okay. Everyone. Yeah. Perfect. Are there any other question before we move to the next problem?
So I guess the one question I had was just the ticket printer thing. So you're saying, like, if you were scaling it out to multiple things, so like multiple parking lots, so each parking lot would have to get its own ticket printer, and that would be associated with that original backend service. Okay.
Exactly. So that's a very good point. So this is more for like, you can ask your interviewer is like, how we want to proceed this. And then you can always, when you ask a question, always propose a solution. That what do I think is, how about we have another database, which is going to tell like this, every printer or every ticket printer is going to have some kind of like MAC ID or physical ID. So we can store that piece of information that this ticket printer is, let's say, a South parking zone, and that parking zone is, it's parking ID or parking zone ID. Then you can just store that piece of information so that you know where the sensor request is coming in, or where you want to send that request back to that ticket printer to print a ticket for you. So yeah, that's a good point, but it's going to require different printers and different sensors for different parking zone, as long as it's not in the one. Okay, perfect. Okay, now I'm going to move to our next one, which is kind of like we use in our day-to-day life, but it's more of a like restaurant recommendation system like Yelp. So we go to Yelp, we find a restaurant, we see what are the reviews for it, we see some photos. So it's always fun to see what people think about it before you like visiting a new place. So let's see. Let's design a Yelp like a website where user can search for I think it's just going to be restaurants. And then user can log in and can also add view comments, photos, and review for the places. Now let's take some notes from this problem statement. So basically, we want to make sure our user can log in. So this is important. And user can log in. That means we need to have some kind of authentication authorization in place. Now, once user can log in, user can actually, like, let's say, comment, view, add or view comments. We're just gonna say comment for now. They can add or view photos, and also they can add review. So these are a couple of things that we took a note from here. Now, let's think through this one, that what we want to do there, and like coming up with some questions. So first is, we know that user wants to log in, but now let's think through this. Can they log in with a new email only and they need to set up password? Or we can use a third-party API like login with Google, logging with Facebook, logging with, I don't know, Twitter. So there are different options. So we need to ask this to our interviewers, like how they can log in. So how they can log in. So for simplicity of sake, let's say they can either log in. We just want to take like 2 examples over here. They can add their email or password, or they can log in with Google. So those are the 2 pieces of information. That's how they're going to log in. Okay, now once they log in, like what's the home screen they're going to see, right? Because like there should be obviously a search bar so that they can search for a restaurant. But once right now they're not searching, so what do they see on the home screen? So there's like a question, and then maybe your interviewer says like, yeah, don't worry about it right now. Let's say they just come, they see just a search screen, there's nothing there, and they're searching a restaurant. So okay, so they want to search a restaurant. Then okay, now they search the restaurant. On the restaurant page, as soon as the restaurant comes in, it should display all of its, let's say, review, the comments on the review, and the photos. So let's say display page of restaurant, review, comment, and photos. Okay, so these are the things that needs to be displayed on this page. And there also needs to be some inputs, or let's say input to add comment, review, and photos. Okay, so there needs to be some kind of input there. Okay, so let's say we ask this question, we set it up the scope, we come on this agreement. Now let's dive into our designing for it. So let's go here. Let's take some notes. Ooh. Perfect. So now we have this note here. Perfect. So user can log in, comment, photo, review. This time around, again, I'm going to be starting with like database. The reason is, do you guys see there are like photos, there are comments on it, there are reviews on it. So there are so many like a relationship between the tables that is currently going on. So we want to make sure that we take care of those relationships. So I'm going to start first of all with table. So let's say we have a table called restaurants. Every restaurant will have an ID. Again, it's going to be an integer, a name, which is going to be a string. Every restaurant will have a ID, its name, let's say address. And yeah, let's say just these are the piece of information for every restaurant that are currently we are storing. Now, going back to this question, how user can log in. So obviously we need a users table. Every user will have their ID, and this ID can be integer. Now they can have their email. Again, I'm going to put just email as a string, or you can use I think here different data types. Now it's very important for yourself to understand any data type. Like if you're using Postgres, you understand what kind of data type is that, because sometimes if your interviewer, they are too much into the database, they're going to ask like, what is going to be the storage capacity when you use this data type versus this data type. So that's why just make sure whatever you are using, you are aware about it. That is like a main thing here. Now let's go back to this. We have, let's say, email, and then we have a password. Obviously we're not going to password as it is. So what we're going to do is we're going to store the password sorry. We're going to store the password in some kind of authenticator manner, but I'm just going to put it as a string, but we always have that middle method so that our password are not stored as it is. Okay. And then if it's a third party, let's say it's a third party, which is from Google, then we're going to store a third party auth token. And we're just going to call again a string or a varchar. Okay. Now let's move forward. We have this user information. We have this restaurant information coming back to this. So let's say photos. Now photos are not necessarily, or at least nowadays, I haven't seen them like store in a binary format in a database. Right now, all the cloud space is very much used for a photo. So you can either use like Amazon S3. There are other cloud services that you can use, but Amazon S3 is like a widely used. So we want to say, like, let's say photos is an table. For this one, we're gonna need a restaurant. Like, let's say for this specific restaurant, this is the photo. So restaurant ID, which is gonna be integer. Let's say which user uploaded this. So we also need like a user ID there. Again, it's gonna be integer. Then the photo is stored where? So like on which location on Amazon S3. So I'm just gonna say location. This can be like a string. And also a photo can be part of the review. So we also want to know review underscore ID, and this can be integer. Okay. Now we say review underscore ID, which is going to be foreign key for our review table. So I'm going to go ahead and create this reviews table. Every review obviously belong to a restaurant. So I'm going to say restaurant underscore ID. It's going to be an integer. Now, every review is going to belong to a restaurant. And it also going to belong to a user. So let's say user integer, and there is going to be some content in that review. So we say content, and again, this, oh, not integer, this can be string. Like, I like this restaurant, they have a good service, they have a bad service, anything. So they can put it in their content. And then last table, but important table, is our comments table. So every comment can belong to a review. So we can say review underscore ID, it can be integer. Also, comment can be made by a user. So we can say ID integer, whoever made that comment, and content of that comment. So whatever they say, like, yeah, you're right, I went to the same restaurant, I felt the same way, any type of comment. I'm going a little faster because we're almost like about the time and I want to cover as much as we can. So that's why I'm going a little faster, but just you all see, like, this time around, we have so many tables, right? It's all about like how we want to design this. Now, we say, okay, these are the table. Let's go ahead and jump into the design. So I'm going to start, first of all, again, with my layer of database. So let's go, and this is database. Now, yes, this website can be used by so many people at multiple locations. So I'm going to, like, even from starting, I'm going to say I have a multiple replicas of my database. So let's say this is database. This is like located in South, and then I'm gonna copy, paste this. Oh, let's say here. Let's say we have 3. One is in the east and one is in the west. And all the database are replicas of each other. That means whatever piece of or I should just connect them like that. It's just like they are connected to each other. Okay. So we are done with at least the database side of things. One thing, going back to like the photos. So do you all remember I talked about that right now Amazon 3 is famous. So we're gonna go ahead and store the photos in Amazon 3. And also that is like, when I say Amazon 3, S3 is like its bucket, and Amazon Cloud is providing that storage to store the photos. So basically that is gonna be another part of my database where my photos are stored, which is Amazon S3 bucket. When they are stored in here, obviously we're gonna go ahead and update our database for that purpose. So I'm making sure that that is connected to my database layer. Now this is my database. Now, again, it's completely up to you if you want to go to your front end first or you want to go to your back end. But I'm going to start again, like coming from database to back end and then to front end. So let me go ahead and create my like layer of backend. Okay, so for backend, what are the endpoints that we're gonna need? So there are multiple things that we're gonna need there. I'm gonna start first of all with, like, let's say user is like signing in. So basically we want the user authentication endpoint there so that user can sign in. Now, do you all remember there are two ways? User can either add their email or password, or they can use like sign in with Google. So basically when they use sign in with Google, that's a third party API. So we're gonna say third party auth API. And like that. Perfect. Let's go ahead and join them. So when user auth, it can either go here, or I'm just going to create like a connection between my backend and my database. Like that. Okay, so my backend and my database can talk to each other. Okay, so once user authenticated, they can either go to the third party. So if they're going through the third party, we want to make sure that the third party is updating my database, right? So we want to make sure that the authentication token has been like added in there. So let me try to make this a little bit less messy, or go here. Perfect. Okay, so if they're going to third party, it has been like recorded there. Okay, now there are two kinds of thing over here. I'm gonna bubble again, or maybe pack them into things. One is like write services and one is read services. So what do I mean by write services and read services? It's let's say they wanna read, oops. Do you remember I said like initially they want some inputs to go ahead and either upload a photo, write a review, write a comment, or see a review, see a comment, or see a photo. So for that purpose, I'm going to go ahead and like quickly create this like a collection or a package. In that, I'm going to say this is going to be a write service. And what my write service again will have is, let's say my write service will have a upload photo endpoint, then write a review endpoint, write a comment endpoint. So these are like endpoints, but I'm going to package them in my write service. The reason is like anytime any other person who's looking into this, it's just really nice to package your things together. So then again, in here, this is going to be my read service. I'm going to say read service. And then for my read service, the task or the fields that I want there is, let's say, see a photo, see, or I should say like a read a comment, or read review. So just packaging them in like a package. Let me make this a little bit perfect. Now, again, depends on which service it is. They're going to talk to my database. If it's a read, they're going to pull things out. If it's a write, they're going to go ahead and write it there. Now, let's go to our front end. So on the front end side here, actually, I'm going to put a little, I'm going to put this one a little on the side because I want to add a load balancer there. Perfect. So here, this is on the front end side. So on the front end side, obviously my user comes and they want to search for something. So let's say we want to tell them like, this is a search request or search view. Once they search or search view, then there is another view that is going to be here is, let's say, write, and I'm going to say only like a write view. Basically, it can be write or slash input view. Basically, either they want to create a review, upload a review, or create a comment. And also another view that I'm going to be having is read view. Basically, they just want to see the photos or the review or the things. This is my front end. Now, this website can be used by 1,000 and multiple people. So always ask this to your interviewer, like, what do you think? How many people are going to use it? And usually you're going to say, like, right now, let's start with a small bunch and eventually want to scale it. Whenever it's like more than thousands of people, it would be really nice to add a load balancer in here. So this is going to be the load balancer. So what happens that is, when the request comes in, let's say we have this load balancer. What we can do now is, if the request is coming in just for like a search, obviously it's going to go to like a read service. Now, what we can do is we can even divide these parts in further. Let's say I want to read, but read is only taken care of by this 5 server, but write is taken care by of 10 servers because writing is going to take a little bit time. So that's why write is going to taken care by 10 servers. Then you can also divide them into different services into different server. Not necessarily all the services needs to be present in the same server. So your load balancer can direct, oh, it's a read request, and let me direct it to the read servers, and no need to worry about directing them to my write server. It's a write one, I'm going to send it to my write services or write server. And then it's an authentication. Let me write to my user authentication server or a service where user authentication is there. So this is your load balancer, can come handy here a lot. Now, one last thing which is important, and I feel like it's really good to talk about is, let's say there is like a new restaurant in the town and like everybody is, there is a article or a blog on it, and now everybody's starting seeing that and everybody wants to just see that. So here, what you can do there at that point is that instead of always go to your database and ask for that piece of information, it's a time consuming process and it's going to take time. So instead of doing that, what you can do is you can have like a service here in middle of your backend and your database. Let's call this like a cache memory. And have you all heard of something called like Rabbit before? Yeah, no. If heard, you can give me like a thumbs up. If no, you can give me like a thumbs down. If this is something totally new that you are hearing the first time. Okay, so yes. So if you have not heard of something called Rabbit, what Rabbit does is, Rabbit is like that middle layer, which is basically caching your database piece of information. So let's say some piece of information has access 100 times more than anything else. This is important. It's better if we're going to cache it, then we can get the fast response. So what happens at that point is that instead, let me do this. instead of directly your backend talking to your database, it's going to first talk to this cache memory and see if that piece of information is there or not. And let's say if that piece of information is there, the cache memory is going to just send it that piece of information from here. Let me just put it this way. And like that. Okay. So if it's in the cache memory is going to return it. But if it's not in the cache at that point, and again, it's accessed multiple times, then your backend is going to talk to your database. And since it's accessed multiple times, what your database will do is your database also going to return it to your backend, but also on top of it, it's going to update your cache memory since this piece of information is accessed multiple times. So cache memory is nothing, but it's going to make your design or your architecture or your infrastructure work faster. Okay. Again, one last connection that I forgot to make, then if it's an upload service, it's going to go to the Amazon S3. So that's, again, a connection that we need to make. So this is a little bit about restaurant recommendation website or a system, that how you can design it and talk about different components. Okay. Are there any questions around it or anything?
Can we get access to the system design question link? I mean, the drive link?
Yeah. I'm not sure how how you're gonna get access to this or not, because the video is gonna get uploaded. What you can do is feel free to send me an email, or not email, but a LinkedIn message, and I can share this link with you. Okay.
Sure. Thank you.
Of course, all the pleasure is mine. Okay, perfect. Thank you, everyone. It was really fun. We went over like 10 minutes, but I felt like it was totally worth it. There was nothing that I wanted to miss. But yeah, this is fun, and I'll see you all in my next session. Bye, everyone.